Next speaker is Anne-Marie Walters, Global Marketing Director, Bentley Systems. She is responsible for marketing and positioning Bentley solutions and products in the process, power, and enterprise areas. Anne is a chartered chemical engineer and represents Bentley on the board of the Construction Industry Institute. She is also engaged in the activities of FIATEC. She was on the board of the Engineering Contractors and Constructors Association between 2005 and 2010 and was the chair in 2009. In addition, she is a founding member of the Process Industries STEP Consortium and has served on the board of CIM Steel. And the stage is all yours.
Good morning, everybody, or it's good afternoon now, although for me it's very much good morning, or namaste as well. My name's Anne-Marie Walters. As Shada said, I'm the Industry Marketing Director for Bentley Systems. I had the honour of addressing you last year as well. And here we are at the 14th Indian Forum, again focusing on the industrial Internet of Things and the age of innovation. And one thing we haven't particularly spoke about is the younger generation and the digital natives. I'm going to be giving a presentation that my CEO gave at the Orlando Forum, which builds on the theme we started last year of asset performance modelling, but makes a case for digital engineering models and how they can support the convergence of OT and IT with ET, and ET being engineering technology rather than ET phone home. I'm going to show you some of the things we've been working on over the past year and some things we announced last year and where they've got to this year. And I have quite a few videos in my slide presentation, so hopefully Raj will bear with me. Just a quick reminder of who Bentley is and a couple of slides to give you an idea. We describe BIM as both better asset performance and better project delivery, that's the B, and leveraged through project delivery and better information mobility to all of the participants in a project, and better depth of information modelling to support the assets across the life cycle. This, if you like, this is where we've put our attention in terms of what we're developing in regards to software. These drive our advancements to achieve lower capex and optimized opex. And overall, and this is a kind of new term that our CEO introduced, overall optimized TOTEX for the total cost of assets. We have a common information platform. We focus very much on engineering, and our common platform's made up of MicroStation on the information modeling side, ProjectWise for the project delivery side, and AssetWise for the intelligent model side, all sharing common engineering environment and common digital engineering models. I should also add these. I should also add these also, our common environment is very open, and we partner with people like Siemens and Microsoft as well. Just that very quickly, we also focus on infrastructure rather than manufacturing industry, and infrastructure means utilities, oil and gas plants, mining, that kind of thing. These are my areas of responsibility. We have a lot of products and a lot of focus areas around infrastructure assets. ARC position us here, and we are covered by two reports for ARC in their market studies, one for engineering design tools, really our project delivery side, on the CapEx side. We're number 2 overall in that market and number 1 in these areas. And then on the operations side, more the OPEX side, our revenues are covered by the asset reliability software and services, and we split our revenues between these two reports. Again, we're number 2 in this market overall, and number 1 in some very similar industries to the engineering side. Last year, we made an announcement of an acquisition of operational analytics, a company called C3 Global and their Amulet software. And we were featured in Gartner's report for asset performance management in this aspect, focusing in on there, alongside, interestingly, GE. And you can see here where they think we're strong. The green areas are where we're strong. And one of the interesting things is, and GE are partnered with a competitor of ours, the number one in the reliability software services market for the asset performance management side. And one of the things we all agree is that asset performance software is very much key to the industrial Internet of Things. And I'll go on a little bit from that. And of course we agree with GE, even though they're partnering with a competitor of ours, we're partnering with Siemens to really combat this, or to work with them. So coming back to Amulet, I spoke last year about one of our case studies, South Australia Water. If you recall, South Australia Water basically provide water in the south of Australia, particularly the Adelaide area, where water is of short supply. In 2009, they won one of our Be Inspired Awards. This is a competition we do annually for the design and construction of a desalination plant to provide fresh water to the region. And fast forwarding on now to 2015, they also won awards for their operational analytics implementation of this desalination plant, plus a pumping network. And they were one of our winners last year for the operational analytics side. And I'm just going to play a short video here of Steve Mitchell, the general manager at South Australia Water, regards what technology and the use of technology has enabled them to do at South Australia Water. Raj?
In South Australia, SA Water has introduced predictive and real-time operational analytics through Bentley's Amulet software, improving customer service while reducing operating costs.
I think the tools we've developed here are an example of the sorts of things that will be very common in the future in industry, especially industry with large asset bases where you've got complex things to operate. It allows you to take a variety of inputs and make the best possible decision. In our case, we've got some sophisticated optimizers we use that Amulet sits around, and it makes a big difference to the way we organize our network and how effectively we can operate.
Okay, thank you. So, basically, Steve there talked about some sophisticated tools that they've used. Basically, they've pulled together demand forecasting tool that predicts when they need, from historical data, when they need to provide water. They've combined that with their network operations model. And if you like, this is the digital engineering model of their assets, their pumping network, their desalination plant, what they are capable of producing. They've combined that with the distribution optimization tool, where they need water to be at in what area, balancing across their reservoirs and their pumping network. And then given that information in real time to their operations people in order to basically ensure that they are producing water and distributing water at the right time to the right people as and when it's been needed. However, it's actually really expensive to run a desalination plant plus pumping water all over the place. So they took this optimized network and this real-time control that they have over their network one stage further, and they because they knew when they were expected to have water, what the weather forecast was going to be like, where they needed to have water, they were also able to optimize when they used their desalination plant and when they used their pumping networks by running those at times when electricity was in least demand and therefore cheapest, in order to get ready for their for their demand. And by doing this, and so they linked all of this to their energy portfolio and were able to negotiate really, really good prices with their electricity provider and save overall, I should go back there. I thought there was another build, sorry. And save overall $3 million in energy costs using this solution. And for that, they've won awards in Australia, and they won awards with us in Bentley. And they also are a case study for Gartner in terms of really integrating IT and OT to deliver business advantage. So asset performance monitoring is bridging the operational technologies on the right-hand side here, with the information technology sides, and South Australia Water is a great example of that. But what about the missing piece? What about the digital engineering models? What also do you know about your assets? The schematics, the 3D models, the functional components, what things are actually there? The engineering analysis, the predictions, the simulation, as the gentleman before me from Siemens mentioned as well. And the network models, as in the case of South Australia Water, they know what their network looks like. All of these things we describe as the digital engineering models. And if you add digital engineering models, they're in a way they're like the DNA of your asset to the baseline and the framework of reference. Then you can really move towards asset performance modeling. Here, our CEO used the analogy of going to a doctor. You tend to go to a doctor if you're feeling ill. He knows your baseline, and he knows what your normal numbers are. And if you're if you're not feeling very well, you'll have a description of how things are going wrong, if you like, and that's your frame of reference. But what if you also knew your DNA as well, how you were made up, what was likely to happen to you? You might be able to do a better diagnosis or even predict something that might be going wrong in the future. Now, if you use this analogy with a process plant, for example, you know the baseline, you know how it normally operates, you know the frames of reference, the history, the IT side of things. You also know, in many instances, the digital DNA, the engineering models of your assets, so you can predict what's likely to go wrong in the future and make decisions to improve the asset life, improve the way it operates, and stop things from happening before they happen, type of thing. And I'm going to show you now some really cool examples of where we've been working in this area, basically. And we also think that the digital engineering models and all of these things are really a key to the industrial Internet of Things. So take for example, take for example, let me just go back a bit. Sorry. Okay, is that going to run a video? I think that I need to run the video here. So take for example a substation, a 3D model of a substation. You now have you can now arm your people in the workforce with a picture of that model, drill into the operating conditions, the real-time operating conditions, what it's actually made up of, and so on. Next video, I think this runs automatically. Also, by means of maps, where there's direct them to where there might be an issue happening, and take them to that point so that they can actually start fixing stuff. Likewise, you have the same drilling into to a 3D model on a process plant where there's an issue. Have a look at the particular item in question, link that to the real-time operation and see where where your window of opportunity is, and to fix something before something actually goes wrong. And we have a really good example. Last year's 2015 Be Inspired winner is this utility company in the UK who have armed all of their mobile workforce, all of the people out on the road fixing things for them in their electrical network, I think it is. So yes, their electrical network, with iPads to give them that information on the fly in terms of helping them make the right decisions when they come to repair the asset. We also had another Be Inspired finalist last year, TNB of Malaysia, who also armed their workers in the field with mobile devices in order to capture what was actually happening and what was actually feed information back in to the system in real time. And they won. They awarded us this year an Innovation in Technology Award for their company. So, but what happens if you don't have a 3D model or you don't have a good asset database? What can you actually do then? So we have here's another example. Exelon, they have a they've taken a reliability-centered approach to maintenance. They've implemented our software for improving that to proactive approach to maintenance. And here's some of their dashboards and their information. But they've also just been given permission to fly their lines using drones to capture the as-is condition of their existing assets. And you may recall last year we made another announcement of a company called Acute 3D, and Acute 3D software, I can't remember the name of the company now, basically, and their software, which we now context capture, which basically turns photographs, digital photographs, into 3D models of assets. Now, and it does so very simply, and there's been an explosion in the use of this technology over the past 12 months since we last spoke to you. In fact, I haven't got it here, but I can show it to you later if you're interested. Working with Siemens, we captured an as-is factory and have implemented the factory around the new production line and so on and so forth using digital photographs indoors as well. So basically, there's been an explosion in devices that can capture photographs. It's no longer just photographs. I'll show you an example a little later of other devices, but whether they're handheld scanners, drones, digital photographs, mobile phones, there's a whole explosion of devices that can capture very, very quickly and easily capture the as-is conditions. And now with cloud as well, basically giving you unlimited access to processing this data, we're getting to the point where instead of just capturing and using it offline, actually capturing the as-is condition in real time and using it as a way of monitoring and controlling and controlling your assets in real time. So take, for example, I think, can you play the video? I think it's gonna, there's a video in the middle, the center video there, Raj. I think I need to press the button again. There you go, there you go. Basically, this is an example of a substation in France where there was, as you see, just about 300 photographs captured from a drone, and then around 180 up-close images taken from the ground. So this is a 3D real-time view, if you like, of this asset. You can get up right close and personal, if you like, and these photographs were processed into one model. And now we end up with a high resolution photograph of that nameplate on that transformer. I'll come back to that in a moment. So basically, this is capturing the as is of your existing assets without having to have a 3D model. Basically, that's the first part of the digital engineering models. So now how do you relate those 3D models to, or those 3D images to actually what you've actually got in reality? Here we've got that same photograph or that same model brought into MicroStation, where you can actually snap to that element, snap to that nameplate, do optical character recognition if necessary, and link it to the data that you've actually got about that transformer in your databases, basically, and then from there bring up the maintenance manuals and things like that. And that gives you the functional indexing. Now, that's all very well if you have a nameplate and a piece of equipment with a nameplate and things like that. But what if you've got a process plant with pipes? How do you functionally index which pipe is which? Now, this is a little blue sky research. I'll play the next video.
Our system can also be used to show the direct relationship between elements of the PNID.
Functional document that's always kept up to date, the PNID. Can you run the video? Is it running?
And the corresponding object in the physical
looking at how you relate
world. By selecting a symbol on the diagram, the corresponding object will be highlighted in reality. And if the user clicks on an object in the plant, the corresponding element will be highlighted in the PNID. This feature will likely help engineers and workers use the PNID drawing more efficiently. For instance, let's assume an engineer must shut down a specific valve in order to inspect a tank. He knows which valve to turn off in the PNID, but he doesn't know where that valve is located in the plant. We can use the augmented reality application as a sort of indoor GPS in order to find a way to a specific machine. We query the path by clicking on a specific element in the PNID, and the augmented reality application shows us the way to the physical plant.
Looking at your plant, what are we actually looking at related to the PNID, basically? But this is sort of work in progress and shows you the kind of things our engineers get up to in terms of creating a user interface on an iPad. And if I go to it's certainly safer than walking around with a helmet on your head in a process plant. Okay. So in addition to functionally locating things, there's also a lot of information you typically have about why things fail. So once you know what you're actually looking at, you can go back and look at why things should fail, and look at what's likely to fail, and so on and so forth, and bring all of this information together into your asset. And that adds the failure mode side of the digital engineering models, linking that side of things to it. So and then from there, you can add alarms and filters, and we've been playing around with a number of ways of highlighting to an operator where there might be issues, whether it's through dashboards, through graphs, through red alarms flashing on maps, through red alarms flashing on 3D models if necessary. How do you home in on how do you use the engineering technology to home in on where you've actually got issues and so on, all from the same engineering data. But going a stage further and coming back to the drone ideas, another thing we've been working with, drones, as I mentioned, they don't always have to have digital cameras on them. This drone has a infrared sensor on it as well, and you can see the infrared on the left-hand side and the actual picture from the digital camera on the right-hand side, and you can see from the drones, as it were, where you might actually have a hotspot and things that you might not necessarily know is happening. So again, bringing this information together. And here's a really interesting case study, or again an experiment that we've been doing, is around the integrating video and video models with engineering analysis of the actual bridge and the accelerometers and movement to identify where there might be issues starting to happen. And as you can see, the left-hand side is the actual video of the bridge with trucks going across it. The right-hand side is motion magnified video integrated with engineering analysis to show where the actual bridge is vibrating and moving. And I'm gonna use my notes for this. Basically, we combined video with, this was an experiment we did with one of our transportation customers. We combined video with the conventional monitoring systems, which basically put sensors on bridges to check for movement, vibration, cracks, that side of things. And we combine, and that gives an indication of where information needs to, where things are starting to go wrong. When you actually combined those sensors with the video sensors and adding the video sensors and the engineering analysis to the bridge, it actually pointed out, it actually added, so if you see the on the, I suppose I could use this thing. Okay. Ooh, over here. Sorry, over here. These are the conventional. These are the places where the sensors are, and these are the points here where the video combined with the engineering analysis added additional information, basically. And the video was able to pick up not only the same amount of information as the conditional sensors, but also was able to add a lot more information about other parts of the bridge that wasn't censored, in order to identify issues and problems. Now, we reckon this is a bridge example, but if you now relate this to, say, a a chemical plant where you might have leaks or vibrations or expansion that's getting worse, that sort of side of things. We reckon combining the engineering knowledge that you know of your plant with the analysis with engineering analysis and simulation, it's not going to be too long before engineers can tell the operations people where to put, not only where to put sensors, but where to put cameras in order to pick up information and have a continuous survey of your asset without having to necessarily put in a lot of expensive extra sensors that may or may not be in the right place. Strategically locating cameras will probably do a good part of the job combined with the engineering models and knowledge you know. So if you like, this is adding alarms and filters to digital engineering models. And then the traditional stuff that we're very well known for, once you've decided you may need to replace, remove, add something, then combining the engineering, the typical 3D CAD engineering tools that we've got. This is adding a new transformer, but adding that into the model of your existing asset, and precisely showing how that will get how you can build it, where you can place it, etc. Adding the new engineering context, the new engineering stuff to the existing asset without needing the model of your existing asset at all. Okay, and so that's engineering context. Last part of the digital engineering models, and I touched on it earlier, is issue resolution in the field. We have a partnership with Microsoft where the first part of this is not only providing the information on iPads, on tablets and things like that, but also having the cloud environment to support continuous real-time access to those people in the field that need it. We have a partner, we're partnered with Microsoft Azure. It provides the cloud environment that we use, and it's very, very secure. I know cybersecurity and things like that are a big concern with people. The Microsoft Azure platform is by far the most secure cloud environment out there. Our oil and gas customers, particularly the global ones, have standardized on this area. So providing, with unlimited cloud access to provide real-time information to the people in the field. We also we're also providing our technologies, whether you're on an iPad, whether you're on a mobile phone, whether you're on a desktop, you get the same experience in terms of being able to share that information back with the office and so on and so forth. And you'll see, this is an example of some of the technologies we're using. This is very much standard technology now in the field and so on. And one of the areas we've partnered with Microsoft, they've brought out a new technology, the Surface Hub, which is a huge 3D screen device to be able to share information back at the office on around people in the field. This is an example here. The same experience whether it's an iPad or on the Surface Hub. And the Surface Hub is now shipping with our technology so that people have this ability to share information regardless of where they are, and our technology will take models from anyone basically. So that's what those are some aspects of what we mean by digital engineering models and bridging the OT, IT, and a gap with engineering technology. All of these different areas. This is where we specialise. I hope it's given you some food for thought, being able to capture the existing asset as is using reality modelling and drones and photography. Linking those images and those photographs with your existing assets through functional indexing, and particularly the work we're doing on the P&ID side, bringing engineering context and doing continuous surveying now in order to really in real time show where things might be going wrong and where things might need some attention. And with that. And basically, as what we've been talking about is connecting ET, IT, and IT, OT with ET to deliver asset performance modelling rather than asset performance monitoring or management. So, if you have any questions, I will take them at the panel discussion, and that's the end of my presentation. Thank you.